Hi, everyone. Welcome to Coding 101. This is kind of a fun course, just a quick introduction to programming. Even if you've never done programming before, no problem. If you have before, great. Hopefully, you'll pick up a few more things. One of the things, why do we do coding, is because a lot of schools don't teach much coding at all. And so it's actually kind of fun to actually do a bit of this to get to see what it looks like and get to use it in a few of your other classes as well. You can watch the video here, but the person who said this, of course, was Steve Jobs.
I was 13 when I first got access to a computer.
My parents bought me a Macintosh in 1984 when I was 8 years old.
I was in 6th grade.
I learned to code in college.
Freshman year, first semester, intro to computer science.
I wrote a program to play tic-tac-toe.
I think it was pretty humble beginnings. I think the first program I wrote asked things like, what's your favorite color? Or how old are you?
I first learned how to make a green circle and a red square appear on the screen.
The first time I actually had something come up and say, hello world, and I made a computer do that. It was just astonishing.
Learning how to program didn't start off as wanting to learn all of computer science or trying to master this discipline or anything like that. It just started off because I wanted to do this one simple thing. I wanted to make something that was fun for myself and my sisters. And I wrote this little program and then basically just add a little bit to it. And then when I needed to learn something new, I looked it up either in a book or on the internet and then added a little bit to it.
It's really not unlike kind of playing an instrument or something, or playing a sport. It starts out being very intimidating, but you kind of get the hang of it over time.
Coding is something that can be learned, and I know it can be intimidating. A lot of things are intimidating, but what isn't?
A lot of the coding that people do is actually fairly simple. It's more about the process of breaking down problems than sort of coming up with complicated algorithms as people traditionally think about it.
You don't have to be a genius to know how to code. You need to be determined.
Addition, subtraction, that's about it.
You should probably know your multiplication tables.
You don't have to be a genius to code. Do you have to be a genius to read?
Even if you want to become a race car driver or play baseball or build a house, all of these things have been turned upside down by software.
What it is, computers are everywhere. You want to work in agriculture? Do you want to work in entertainment? Do you want to work in manufacturing? It's just all over.
Here we are, 2013. We all depend on technology to communicate, to bank, information, and none of us know how to read and write code.
When I was in school, I was in this after-school group called the Whiz Kids, and when people found out, they laughed at me and, all these things. And I'm like, man, I don't care. I think it's cool, and, I'm learning a lot, and some of my friends have jobs.
Our policy is literally to hire as many talented engineers as we can find. The whole limit in the system is just that there just aren't enough people who are trained and have these skills today.
To get the very best people, we try to make the office as awesome as possible.
We have a fantastic chef,
Free food,
breakfast, lunch, and dinner.
free laundry.
Snacks, even places to play and video games and scooters. There's all these kind of interesting things around the office and places where people can play or relax or go to think or play music or be creative.
Whether you're trying to make a lot of money or whether you just want to change the world, computer programming is an incredibly empowering skill to learn.
I think if someone had told me that software is really about humanity, that it's really about helping people by using computer technology, it would have changed my outlook a lot earlier.
To be able to actually come up with an idea and then see it in your hands and then be able to press a button and have it be in millions of people's hands. I mean, I think we're the first generation in the world that's really ever had that kind of experience.
Just to think that, I mean, you can start something in your college dorm room, and you can have a set of people who haven't built a big company before come together and build something that 1 billion people use as part of their daily lives is just crazy to think about, right? It's humbling and it's amazing.
The programmers of tomorrow are the wizards of the future. You're going to look like you have magic powers compared to everybody else.
I think it's amazing. I think it's the closest thing we have to a superpower.
Great coders are today's rock stars. That's it.
All right, enough on that one. So we're going to use the processing language. It's just one of many, many different coding languages we could possibly use. And so the question I always get asked is, why not use Sketch, Python, C++, Java, or Node, just to name a few other languages? Processing's not perfect, but it allows super easy access to video, graphics, sound, mouse controls, animation. And its language is very similar to Java, which is the language that's used in the AP Computer Science course. So it's a great introduction to that if you've never seen it before. Here's what the processing environment looks like. It's very, very simple. You type your code in here. This is the run button. It runs your program, and it's literally called the sketch. This is the stop button. Over here, enable debugger. You won't need to use that. Current mode, which is going to be Java for you. This is where you type your code, as I mentioned before. Down here is message area, where you get output from your code, and you can sort of see what's happening. In every single sketch or every single processing program, there's going to be two parts. There has to be something called void setup with a set of parentheses. And inside of these, I call them curly Q brackets, is where you put your code that you want to do in the setup. The setup part of your code only runs once when you hit the run button. The draw part of it, there's another one called void draw, open close parentheses. Any code that you put between these curly brackets gets done over and over again 60 times per second. And you can change that later if you want, but for now, by default, it does it that fast, very, very quickly. And you might say, well, why would you want to redraw things that fast? Well, if you draw them that fast, you basically create an animation. And to talk about animations, we need to talk a little bit about how computers do graphics. Normal graph paper, this is the origin, usually the middle here. This is the positive x-axis. This is the positive y-axis, negative x, negative y. Well, you'll notice this fourth quadrant here is kind of shaded, and that's the way that computer screens work. The very top corner of your screen is defined as 0, 0, with this direction being the positive x-axis, just like down here. But now here's the bizarre part. Going down is increasing y. So this is the positive y-axis. So 0, 0 here, positive x this way, positive y down this way. And you might say, that's kind of strange. Yeah, but at least it's consistent across all computer screens, that the upper left corner is your origin, and then you work positive to the right and positive down, no matter what the size of your screen is. So here's one of the first processing programs I want you to do. What this does, first of all, in the setup here, it sets the size of the screen. We would like our screen to be 800 pixels wide and 600 pixels tall. And then we're going to draw a line from coordinate 10, 10 to coordinate 500, 500. Now, braces again, remember, around your code. So it just says, hey, do this piece and during the setup, do this line during the draw part. Every line, that's not a definition of a part here, ends with a semicolon. So always remember that. That's actually one of the more annoying parts of most languages, is they have some sort of terminator at the end of the line. It turns out you don't have to have your code perfectly lined up. So for example, you could literally put that entire program like this: void setup, open brace, size this, semicolon, close brace, void, draw, open brace, that, semicolon, brace. It works just as well as the original program. Or you could write it this way if you want to be creative, or even this way with large spaces and gaps in it. And believe it or not, all this code works well. But just like in English class, you have a certain format for, mentioning your references. Typically, there are certain style points that all programmers use. So what do we usually do? We usually indent our code slightly. So the lines inside of setup go here, the line statement goes here. And so when you run this program, which will be your first one, you'll have it sets the screen up 800 wide, 600 tall, and then it's going to draw a line from 1010, that's 10 over, 10 down, to 500, 500, which is 500 over, 500 down. And I know I don't have these exactly the right spot, but when you draw these, you should see something like this, hopefully. Ignore the bell. So that's our line statement, the initial X and initial Y to the final X and the final Y. And yeah, you can have multiple line statements in your draw, and it'll just keep drawing them all as well. Interestingly enough, 0, 0 is a point. So if I say it goes 800 wide, it actually goes from 0 to 799, which is actually 800 points. And when I say it's 600 tall over here, it actually goes from 0 up to 599, because 0, 0 is one of the points, and so therefore it is exactly 800 by 600 pixels. This code will draw two lines, one along the top of the screen from 0, 0 to, let's see, it goes from 0, 0 to the X coordinate 799, 0. So it's going to draw a line right across here. And this line is going to start a line at X 799, 0 down to here. And so what I want you to do is to add two more lines that go across the bottom and back up to the top. So where would you add the code? It should just go down right here below these other two lines. And again, just for style points, you would probably indent them so they're equally indented to these two. And this is your first checkpoint. Because you're all going to be working through this independently, when you get this rectangle on your screen, call one of us over and just show us so we can say, okay, yep, you got this one, you're ready to move on. Adding color. The stroke command actually allows you to change the color of whatever you draw, which makes it kind of fun. I don't know if you ever realized this, but your computer screen actually has red, green, and blue pixels. If you looked at it really close under a magnifying glass. And by varying the intensity of the red, green, and blue, you can get all the different colors in the spectrum. So in this case, you can specify the intensity of the red, green, and blue by specifying a number between 0, which is none of that color, up to 255, which is the maximum of that color. So for example, the stroke command down here sets red to 255, the maximum value, and green to 0, and blue to 0. So after this command's executed, these two lines are going to be bright red with no green and no blue, which is kind of cool. Now you can mix colors as well. Now this is unlike paint. When you mix light, you get some interesting colors. So of course, 25500 is red, 255 is green, 255 is blue. But to make yellow light, it tricks our eyes. If you use red and green, it makes yellow. If you use green and blue, it makes cyan. And if you do red and blue, you get magenta. And of course, you can get all kinds of colors in between those as well. How do you make white? You can kind of guess. It'd be all the numbers are all at 255. How do you make black? 0, 0, 0. And you can do any numbers you want in there as well. If you want a particular color, that's not just one of the base colors, if you go to your tool menu, you can actually go to the color selector button, and then you can just simply drag your mouse around to whatever color you want, and it'll tell you what the red, green, and blue values are for this particular color. And then you can use those in the stroke command to get the exact color that you want, which is kind of nice. So we made a rectangle before using the line command. It turns out there's a command built into processing to draw rectangles. You would think it'd be called rectangle, but they shorten it to make it a little bit easier. It's just called rect, R-E-C-T. And what you specify here is the top left, right, or this top corner over here, the top pixel where you want this. And then you specify the width and the height. And it automatically will draw a rectangle of the width that you specify, starting at the coordinate you specify, and of the height that you specify this way. What color will it be? Well, by default, black, unless you use a stroke command first before it to set the color to what you want. And you can draw a rectangle anywhere you want on the screen. So in this case, it'll draw a rectangle right at 0, 0 with a width of 100 pixels and a height of 100 pixels. And you can try this real quick, and it should do it pretty nice. You can also control, though, where you specify it. There's the rectangle mode command. And if you tell it, hey, rectangle mode center, what it does is then draws the rectangle not with that top corner as being the upper left corner of the rectangle, but what it does now is it makes this point 0, 0 the center of the rectangle. If you run this command, what actually happens is it draws the rectangle off the edge of the screen. You don't see the rest of it, but it draws it like this, with the 0, 0 point in the middle being 100 across this way and 100 up this way. But what do we see on the screen? We only see 50 by 50 because 3/4 of our rectangle is now off of our screen completely. And it doesn't bother processing if you try drawing off the screen, it just doesn't show it, which is kind of cool. All right, moving on. So you can also play a little bit with this. I'm going to introduce, the stroke command controls the lines. There's also a fill command where you can specify the color you fill it with. So in this case, the stroke color is red, so that's why the line here is red. And the fill color is maximum red and maximum green, which produces that nice, beautiful yellow color you see right there. And now if you draw the rectangle, it draws the outside of it with red and it fills the inside with yellow. And you can also use the no stroke and no fill method to make them transparent. If you don't want to have a line around the edge, or if you don't want to fill the inside, you want to leave it transparent, you can use those commands either to turn these parts off, or even before you draw the first rectangle without setting these, you can make it not draw those lines. There's also an ellipse command. And you're like, what? What's an ellipse? Well, ellipses, you might say, well, ellipses are those funny shapes that are kind of oblong like this. But wouldn't it make more sense to draw a circle? Well, please realize that a circle is just a special case of an ellipse. The commands for an ellipse, you specify the center of the ellipse, and then you specify the width and height of it. If you make both of those equal to each other, the width and the height, you end up with a perfect circle, where it's 80 across this way and 80 across this way, with the 100 point here right in the center. In this case, the stroke is black, and the fill color is that blue that we saw a little bit earlier, which is kind of nice. This is your second checkpoint. Could you please show us when you get with at least one completed ellipse? You can do a few more. You can change the colors, change the stroke colors, but at least show us at least one of these. All right, adding a couple other shapes. Yes, there is a point method. This draws a single pixel at that point with whatever stroke color you have, in this case black. And there's a triangle command, and you might have guessed here, these are the 3 X and Y coordinates that specify the 3 corners of our triangle, which it then draws with whatever stroke color you have, which is kind of a cool way of drawing triangles. Finally, for those of you who've worked in Photoshop or any kind of other graphics one, you know that you can also make images transparent. Well, there is a fourth option to each of these things, an alpha component. Alpha means opacity, and it's particularly useful when you want to draw elements that are partially see-through. So alpha values also range from 0 to 255. With 0 being completely transparent, I don't know why you would ever want to make something completely transparent, unless you want to make it disappear, I guess. And 255 is completely opaque. In other words, you can't see through it at all. So 255 really, really thick, or you can't see through it at all. So try these real quick here. So in this case, the fill color, this is 90% opaque, which means it's 10% transparent. And this one is, when you draw this rectangle, it's going to be completely opaque. In other words, you can't see through it. And if you try this code, you'll actually see it. You can add a few more if you want as well. But when you get this one, this is your third checkpoint. Show us your transparent rectangles, which will be kind of fun. This leads us into our next piece here, which is the Zoog game. The Zoog game, we're going to draw this alien, and we're going to try to catch him in a bucket. But our first step on this one is just drawing the alien itself. So this is a lot of drawing. We're going to set the background. We haven't talked about this before, but this sets the background of the screen to white. Maximum red, maximum green, maximum blue. We're going to set the center, or ellipse mode to center, so it draws from the center, rectangle mode center. We're going to set the stroke to black and the fill to kind of a gray color. And we're going to draw this rectangle. This is going to be the body part right here. Then we're going to draw an ellipse, or set the fill color to white, draw an ellipse. Set the fill color to black, draw the two eyes. Then we're going to draw two lines here, which are the legs. And then a new statement down here. This stands for print line. And it's a shortcut. You shorten line to just LN. Take me to your leader in quotation marks. And this is going to show up in our console window down below. You can also give Zoog blue eyes. And you could make Zoog into a ghost by making him slightly transparent. And so this is your fourth checkpoint. I'd like you to show the program working with Zoog with blue eyes. So you're going to need to modify it slightly. Right now the code's going to give him Zoog black eyes. I'd like you to give him blue eyes. I don't know if it's a him or her, but I'm going to say him on this one. And once you get that point, just call us over so we can do the checkpoint for you. And now Zoog 2.0. This is going to introduce the idea of variables. Right now, Zoog always gets drawn in the exact same spot, but it'd be nice to be able to modify that. So in your code, oh, by the way, notice I've moved things around just a little bit here. I put the braces like this and like this. Why have I done it that way? Just to make the code a little bit more compact so I can fit more on the screen at one time. Please remember it doesn't matter too much. But I need to explain real quick what variables are if you haven't run into those. Variables are just like those you use in math class, but you need to tell the computer what kind of information you're going to put into that variable. There are integer variables, double variables, which hold like floating point numbers like 3.2, character variables, which hold a single letter, string variables, which holds a whole bunch of letters in a row, like take me to your leader, and a Boolean variable can either be true or false. In this case, I want to store the number 100 in the variable called x, so I'm going to define it as an integer variable, and I'm going to store this number 70 in the variable called y, and I'm also wanting to be an integer. Now, I could have called these variables anything I wanted to, but x and y is convenient because now what I can do down here is I can say, hey, I want to draw Zoog at these coordinates. What's going to be so nice about this is once I do this, if I change x and y, Zoog is going to move to new x and y coordinates, which makes animations much more powerful. So, what I'd like you to do is, first of all, if you haven't already finished this one, finish this with the variables involved. And then I'd like you to do this inside of your code. X equals x plus 1. Now I need to explain what's happening here. So remember, original x was 100. What does this do? It takes the original 100, adds 1 to it, and then stores it back into x. So x becomes 101. Y was 70, and so what it does is add 1 to 70, makes that 71, and then stores that in the variable y again, and now draws our Zoog at x equals 101, y equals 71, and then remember this executes multiple times. Please remember you have your variables up above here yet, and your setup is still up here. But now next time through, x was now 101, adds 1 to it, becomes 102. y was 71, adds 1 to it, becomes 73. And so what's going to happen to our Zoog? Each time through this loop, it's going to draw Zoog at a new location, which is kind of fun. And so what I'd like you to do is once you get that working, grab us over and show us checkpoint 5, which is showing your working program with a moving Zoog. Zoog is going to move off the screen, though. I need to warn you. So you got to show us as you first start your program. Otherwise, Zoog is going to go off the screen and you won't see Zoog again. Zoog will disappear. All right. Finally, it'd be nice if Zoog didn't go off the screen each time. So one way of fixing that is to actually check the X and Y values. And if things go out of control, we move it back again. Now, we'll talk more about the if statement later. But right now, I just want to introduce it to you. It says, hey, if X ever gets less than 0, in other words, if Zoog goes off this side of the screen, and now this part right here, 2 parallel lines upward. By the way, those parallel lines are, if you do shift and the key above your return key on your keyboard, you'll find those, but you got to do 2 of them in a row. This stands for OR. So if X gets less than 0, or X is greater than the width of the screen, in other words, Zoog is going off the edge of the screen this way, then change. And by the way, we're adding 2 new variables here, X and Y. Then change, right now increment X is 1, which is going to move Zoog this way across the screen. If we go off this end or that end, we're going to change the sign of that 1 to -1, or if it was -1 to 1. The same thing we're going to do with the Y. If a Y is less than 0, in other words, Zoog is going off the edge of the screen that way, or Y is greater than the height of the screen, we're going to change the value that we're incrementing here. So why is that so useful? Well, you'll see in just a second when I clean this up a little bit. Those variables are going to specify how many pixels we move around each time. Yes, you could change that to 2 or 3, and it would actually make Zoog move faster on the screen. And then this statement's down here, again, we talked a little bit about. It adds whatever that variable, instead of always adding 1 like we did before, you can now change it. You make that 2, this increments by 2. That's not so useful. But the code down here is the critical part. If the image hits the side of the screen, we negate the value, the increment value. And by the way, width and height are automatically defined when we define the size up here in our program, which is kind of cool. When you get this working, so here is a little bit more of the code. You still have your setup command and the other parts on this one. But we're going to do one creative thing on this one. We're going to move your Zoog, the part that draws the Zoog, into its own section of the program. So I'm trying to draw around this real quick here. We're going to create a method called drawZoog and put all the code that was up here. You can copy it, paste it down here. And this is the part where we actually draw the Zoog character. And now, instead of putting all that code up here, we can simply use this command right here, say drawZoog. And when the code runs into that, it's automatically going to do this and draw our Zoog. This just makes our code a little bit easier to read. So now our draw method isn't so hideously huge. It's just increment the X. If it goes off the screen, change it. Draw the background as white, and then draw our Zoog, and then come back around and change it again. This is much easier to read than the other parts. By the way, we could call this method anything we wanted, as I mentioned over here, but drawZoog is a good, nice, clean way. So if anybody else looks at your code, they're like, oh, okay, this is where we're drawing the Zoog character. And there's what we call the method. At this point, once you get this going, you should have your bouncing Zoog around the screen. This is your 6th checkpoint. Make sure you call us over and show us your bouncing Zoog. I want you to try this real quick. What would happen if you remove the background command? Remember, this makes the background white. Try just removing that for a bit and run your program again. Something very interesting happens, and you'll enjoy it, but try it real quick. It gets a little bit bizarre real quick. This next piece here, you might want to save your old program and just make a new one real quick. Well, copy paste the code first. I'd like you to actually change it a little bit. Take out the increment parts here. You can take out the variables here. And instead, I want you to say x equals mouse x, y equals mouse y, making sure you follow the capitalization rules here. And these are predefined variables that always hold the x and y position of wherever your mouse cursor is. We're still going to call the draw Zoog down here. And what you're going to discover is when you run this one, you should discover that every time around the loop, the x and y variables are updated to where your mouse is. Zoog is going to follow your mouse around the screen. And this is your 7th checkpoint. Again, you can save this program with another name, maybe follow Zoog. Show it when you get it working, and we're ready to move on. Images is our next step. Images are really useful when you're doing games, and you can sort of guess what we're moving into here. We're going to create a new variable. All of these other variables have been storing integers, and I told you there's doubles and chars and strings. We're actually going to create a whole new variable, and this type is called p-image. And you're like, p-image? Yeah, P stands for processing image. So we're going to create a variable called I, and you could have used any letter you wanted or any name you wanted. But this is going to be, this variable, instead of storing an integer, is going to be able to store an image. So in the setup part of our program here, besides doing the size, what we're going to do is use a new thing here called load image. And we're going to give it a URL. This is the science server here at Concordia. And I want you to put in this. And this is the Concordia logo. What it's going to do is go out to the web, grab that image, that GIF image, and store it in the variable I. By the way, I'm missing my brace here. I don't know why it's disappeared there. There we go. And that's only going to happen once. And now in our draw method, instead of drawing Zoog, we're going to do this. We're going to say, hey, and this is the new command you haven't seen before. It's called the image command. It says, hey, draw the image stored in the variable I at the coordinates x and y. And again, I'd recommend making this a new program. And what's going to happen here is if you get this working right, you should have a bouncy Concordia logo around your screen. So when you get this code working, call us over so we can actually see your bouncing Concordia logo. And this is checkpoint number 8. Again, you can work through these at any speed you want, so don't feel like you're in any kind of rush. Algorithms, which is our next step. We'll talk a little bit more about it. Algorithms are a set of steps to solve a problem. It could be anything like brushing your teeth, estimating square roots, tying your shoe, demolishing buildings, calculating slopes, landing on the moon, automatic parallel parking. So here's how babies make decisions, just to sort of see an algorithm. Is it food? Yes. Stare at it, poke at it, drop it on the floor, smash it, throw it, rub it in your hair. Is it food? No. Try to eat it immediately. If you've ever seen babies, they put everything in their mouth. So this is an algorithm. Why? Because it has a series of steps to figure out what to do. And it's a crazy simple one. I understand that. How good is your algorithm? Well, there's correctness and there's efficiency. There's a lot of different ways of putting peanut butter on an apple, but there's some ways that are better than others. And so you want to try to always make your algorithm as efficient as possible. In our Zoog bucket catch game, what we're going to do is, your game is Zoog's going to fall down randomly from the top of the screen, and you're going to move the bucket back and forth with your left and right arrow keys and try to catch Zoog in the bucket. So what we're going to do is this. We're going to create a couple new variables. One is the bucket X position, the score, which we're going to set at 5. We're going to load the bucket image, and just to make it a little bit easier, we're going to create the variable time. Instead of calling it I this time, we'll call it bucket, which makes a little more sense. We're going to set X, this initial starting point of our Zoog. And it says something interesting here, random of width. Random generates a random number anywhere between 0 up to the value of whatever value you put in here. In this case, and then int converts it into an integer. So if random of width comes up with 47.5, this simply makes it 45. Just converts it to an integer. And then Bucket here loads the image of a bucket from the Concordia server. And what's going to happen here is it's going to, a couple of quick things here. We're going to work with text. Again, fill command actually specifies the color of your text. This is the size of the text. We're going to draw up in the top corner score, and then whatever is in the score variable as well, and this is the x and y coordinates of that. We're going to increment the y values of Zug, and we're going to draw the bucket at bucket, or here's the image. We're going to put it at bucket x, which initially is going to be 10, and the height of the screen minus 150. So starting up here, if this is the bottom of the screen, it's going to draw the bucket just above the bottom of the screen. So get this code in there, and you can stop and rewind the video if you need to. But then we're going to need to add one more thing. We're going to add a new method called keyPressed. And this is the part where it gets interesting. KeyPressed gets automatically called. We're not even running, or we don't even call this function inside of our code. KeyPressed is a special type of method that automatically gets called every single time you press a button. And whatever button you push on your keyboard comes back with a key code. And so in this case, we're saying, hey, if the key code you just pressed was the left arrow key, which we specify capital L-E-F-T, it's predefined in it, what we want to do is make the bucket x equal to bucket x minus 5. In other words, we're going to move the bucket this way. Likewise, if the key that we pressed happened to be the right arrow key, which is defined as capital R-I-G-H-T, we're going to add 5 to the bucket, which is going to move it this way. So checkpoint 5, once you get all the other code and this, we're going to have a code which is going to have a falling Zug and a bucket that you can move back and forth using your left and right arrow key. When you get that one, go ahead and show us, and again, save your code, and that's your 9th checkpoint. Now, scoring. There's one little point on this one here that we want to do this. So we're going to add a little bit more code here to the draw one, and it's a little bit long. In this case, what we're doing is checking to see if the x position is within the bucket's top and the y is less than or equal to the height of the bucket. We're going to increment the score. Now, this is a shortcut notation. We could have said score equals score plus 1, but this is a shortcut that a lot of programmers use. If you simply put plus plus, it simply says, hey, just like if you're counting, just add 1 to this variable. And it's the same as writing all of this out, but this is a shortcut. We reset y back to 0. In other words, put Zug back at the top of the screen and choose a random x position at the top of the screen, somewhere along here to start Zug out. Else, if y is greater than the height of the screen and we haven't actually scored, what we want to do here is just change the text size to really big, change it to all red, and put game over roughly in the middle of our screen. If you would, please. Again, remember, you still have to have your key code down below here. You still have to have your setup and your variables up above here. But when you get this one running, save it again as maybe a different name. And this is checkpoint 10. Show us your working Zug game with a falling Zug, moving bucket, and scores up on the top. Each time you were able to land Zug in there, your score should increment each time. And if you miss Zug, it should give you the game over. All right, with that, you should be in pretty good shape. Our next step is actually moving into sound, which we'll save for the next video. All right, have a good time. Hopefully you've had some fun with this, and we'll talk to you soon.